2, 3. Today, viewers, we are going to look at Exam 2, Version 4, Problem 3. The Problem 3 states, the rate of change of the magnetic field through a loop is 0.08 teslas per second. If the ends of the loop are attached to a voltmeter, what average voltage does the device display if the loop is a 2 meter by 5 meter rectangle? First, let's make a diagram. What we have here is our voltmeter, or our device, and it's going to be hooked up to our rectangular loop, which is going to cause an EMF through the loop and is going to display on the device. Now, why does that happen and how does it happen is going to be explained. First, let's define our EMF, or our average voltage. It is electromotive force. The electromotive force is known as an electric potential, which is the amount of energy or joules per unit charge or coulomb, which we know to be voltage. And in order to solve our problem, we're going to use what's called Faraday's law, which states that the average EMF, or the average voltage, is equal to negative N times delta magnetic flux over delta T. The negative sign in this equation is due to Lenz's law. But in this problem, we're not worried about the direction of the magnetic field. What we are worried about is the magnitude of the EMF.
Dr. Alfred. Stand. Sorry.
Magnitude of the EMF. Okay. In order to find out the average voltage produced, we have two situations. Situation 1 is our average voltage is produced due to a change in magnetic field through a constant area of the loop. Situation 2, we have a change in area and with a constant magnetic field, which produces our voltage. Looking at the equation, back to Faraday's law, magnetic flux is defined as the magnetic field times the area times the cosine theta. Our cosine theta is due to the angle of the relative angle of the normal surface and the magnetic B field.
It's the angle between the B field and the normal of the surface.
And the normal of the surface.
Mm-hmm.
So, what we have here is a change in magnetic field. So we're going to go with equation number 1. So our EMF is equal to N, number of loops, which a loop, so N is equal to 1 loop, 1 loop. Our area is a rectangular loop, which we have here is 2 meters by 5 meters. So the area of a rectangle is length times width, which we find to be 5 meters times 2 meters. And our change in magnetic field through a loop was 0.08 teslas per second. So we do the math. We have 10 meters squared times 0.08 teslas per second, which gives us 0.8 volts, which we find is our average voltage the device displays. And that is how you solve this problem. Okay.